Hi, my name is Shari Rasan, and today we'll be learning about the basics of machine learning. And we'll be using a website called Kaggle.com to learn more about machine learning and its basics. And Kaggle is a huge data science website owned by Google, where you can also participate in a ton of data science competitions, and it provides a lot of data sets, so it's really good to learn machine learning from there. So to learn more about machine learning, we have to first know what supervised, unsupervised, and reinforcement learning are. So supervised learning uses machine data that is already labeled, where the correct output values are already known for part of the data. And from this complete part of the data, an algorithm is able to predict a specific target for the new data given. And a target just means that a specific variable or feature is the output that needs to be predicted. And labels just means that for a given set of inputs, there's a specific output that we need to find. So that might sound a bit confusing, but let me give an example. So let's say we're given a set of data that has the amount of legs, color, and other features of an animal, including if the animal is a cat or dog in the training data. So then the algorithm is trying to predict if that animal, based on the data, is a cat or a dog. So the data is then trained and fitted using an algorithm. And from that, when we're given new data that we can actually test our algorithm on, then it can see if that is a cat or a dog. The new data doesn't specify if the animal is a cat or a dog, but the training data does. And the target we're trying to find here is if the animal is a cat or a dog. Unsupervised learning is when there's no labels on the data. And unsupervised learning doesn't have any data to actually train with previously, meaning we don't have any answer or specific classification for the data we have. So an algorithm tries to find patterns between the data. And the actual target, unlike supervised learning, is not a specific thing we're trying to find. We don't necessarily know what the exact target is. We just know that the data is being grouped together and classified based on a certain pattern that we're not sure of. So an example of unsupervised learning is, let's say we're given features like gender, location, age, and a ton of other features of a ton of people, including a product which they've bought and what time they buy these products. And this data is grouped together into classifications based on patterns between all the customers, possibly showing different types of customers in that data. So one group of data might be, customers that buy specifically technology, and another group may be customers that usually shop during the daytime. But we're not exactly sure what that specific classification could be. And that classification itself is the target. And lastly, reinforcement learning is when we reward certain actions to make progress towards some goal. An example is progressing through a game like Mario, where Mario needs to get to the end flag by moving to the right. So now I'd recommend to go to Kaggle.com and click on courses. And we're just going to go straight to Intro to Machine Learning, but if you need help on Python, you can start at Python, or you could also look at OPL's videos for Python. And now click Intro to Machine Learning and click on the first lesson, How Models Work. So this first lesson is just really an introduction on what a decision tree is. It's a supervised learning algorithm where it constantly asks a ton of if statements. In this example, we're given a set of data that has a ton of houses and a ton of data on those houses, like its room, the latitude and longitude of the location of the house, its address, and its lot size, and a ton more. And what we're trying to predict is the price. So what a decision tree does is, based on on all of the data, it uses a ton of if statements to check if the price should be this price or this price, based on if there's two bedrooms. And now this seems pretty simple and doesn't seem as exact, but once we put in a ton of more variables into it other than bedrooms, like lot size, then it could be much more complicated and be more specific. So that's what a decision tree is. Now let's go to the second lesson, examine your data. Finally, we could get into some actual Python code. Our first line would be import pandas as PD. And this line of code just basically means we're importing the pandas library, which gives us a lot of tools and methods for using our data. And a library just means a large collection of code that allows us to use tools that library provides. And this is so we don't have to code and reinvent the wheel. for those same tools that are already out there. And an important part of this library is the data frame, which is essentially like a table, and it organizes the data into an easily readable format. So for this example, we'll be using home prices in Melbourne, Australia, similar to the example in this decision tree. So after our first line of code, now we can save our file path into a variable, which is this file path, which leads to a CSV file. And finally, this is a very important line. Basically, we're reading and storing the Melbourne data into a data frame, so we can see and use the data effectively, using the read_PSV method. We store this data frame into a variable called Melbourne data. And then now we can use the .describe function, which basically gives a statistical analysis on the data. So on the bottom, we can click first coding exercise, which is still part of lesson 2, but now we can do the coding practice. So in the coding practice, we can use what we learned and actually test out the code. So this first block of code, you don't really need to understand it, but it basically just sets up the checking for our other blocks of code. And you should always usually run the first line of code in these coding practices. Otherwise, these other blocks may not work. So just run it, and now if we get these ones correct, it'll say correct on the bottom. So this next block of code is like what we just learned. Basically, the file path is put into a variable. And now we need to read and store that file path into a data frame using the read_CSV function. And now we can run it, clicking on the arrow on the left. And it says correct. And if you ever get stuck, you can just uncomment this solution, and then it runs that. So now we need to print out a summary statistics. Basically, just like we learned, we use a describe function. We'll do home._data.describe. And this shows a ton of statistics on our data, like the mean, which is like the average, and the maximum and the minimum. And the next question just asks some simple questions about some statistics, like the average lot size. And if we see the average lot size, it's this number right here. And we can check that using our solution. Okay, now on the bottom, we can click your first machine learning model, which goes on to lesson 3. So the first block of code is just like we learned last time, where it takes a file path, then it reads it with the data frame, and now on this new line of code, it prints out all the columns. And these columns are specific variables or features that is in the data set, so like the rooms, the lot size, the year built, bathroom size, bedrooms. And the reason we're printing out all of these columns is because we need to pick and choose from them, since we don't need all of them when actually training our data. There's some features that wouldn't necessarily be needed when fitting our data, and it might just confuse it even more. So we'll only pick and choose the ones that we really need. So this next line of code just drops all of the houses in the data set that have missing values. Later on, we'll learn how to actually utilize those houses, but for now, we'll just drop them. Next, we need to select the precision target. If you remember what the target was, it's basically a specific variable that we need to predict for. And in this case, we need to predict the price of the house. So from the data, we'll do melbourne_data.price and make it into a variable y, which is specifically what we're trying to predict. Next, we need to choose features, picking from the one using melbourne_data.columns. And here's an example of some of the features we'll use. We'll put all the features that we need into a list called melbourne_features. And now from the data, we can collect all these features and put it in X. So X now has all of the data that we need from the Melbourne data, but only for those specific features, such as rooms, bathrooms, land size, latitude, and longitude. And now when we do x.describe, instead of showing all the statistical analysis for all of the data, it'll just show for these specific features. And next, we can do x.head, which basically just shows the data of the first few houses, only for those specific features that are in X. And next, we can actually build our model. So from, just like we learned before about the decision tree, we can use sklearn, which is a library that has a ton of algorithms that we're able to use. And it's the most popular library for modeling types of data, usually in data frames. So in here, we're collecting the decision tree model. And we use random state equals 1 to ensure that the same results will be run every single time, which is usually a good coding practice. So now our decision tree is in Melbourne_model. We can now fit the model and train the data here. And the way we do that is first we get all of the data of the specific features we have and specify what target we're trying to predict for. And this is done using the fit method. So to recap, what we first do is put the data into a data frame. Then we find the prediction target, which is y. And then after that, we find the features. And then using those features, we find all of the data that subside in those features. And from that, we're able to get a model, which is our decision tree. And then using the model, we can now fit our data, using all of our data from those features and predicting for y, which is the prediction target that we specified earlier. So our next block of code is not exactly how we would be using the model we fit. Essentially what we did was use a fitted model and predict the prices for the x.head, which is just the first few houses in the dataset. This means that we're using the data that we already trained to predict the prices for that data, even though the prices are already in the original dataset. Ideally, we would want new data with those input features to predict the house prices, but this code is just to show how the predict method works. So after we finally predict our prices for the first few houses, even though they already have prices for those houses, we can actually print them out and see what those predictions are. Now let's click model building exercise. Remember to run the first block, which is basically everything we did in the past lessons. So first we gotta just print out a list of columns in the dataset, and so we can finally choose from them. So home_data dot columns. These are all of the columns we have. Next we need to specify our prediction target, which will be the price. So now of course we need our features, so let's put them in a list, and we can just copy them from here. And these are the specific features that we actually are going to be using when training the data, leaving all the unnecessary ones behind. So now that we declared all the features, we need to actually get the data corresponding to those features. And the way we do that is just home_data feature underscore names. Now it's asking us to review the data. Basically print a description or statistics from X. And if you remember from before, we can just do x.describe. And now it's asking us to print the top few lines, so the first few houses. And if you remember, that was x.head. And let's run both. There we go. And now here comes the fun part. We can actually specify and fit our model now. And if you remember from before, we were using sklearn library, and we're using the decision tree regressor. So from sklearn tree, and now we need to declare a model, and we need to remember to do random state equals 1 to have the same results every time. And now we can actually fit our model using the data for those specified features and our prediction target, so x and y. And let's run it. And now we can actually predict. So we'll be using x for our data, but usually, like I said before, we should be using new data, but for now we'll just use x. And for this we'll be using the predict method. And these are the specific prices that it predicts. And now over here it's asking us to compare. So we can use x.head to actually compare our prices versus theirs. And so this is a brief summary on everything we did today so far, and we're actually able to make our own AI. And next lesson we'll be able to compare our predictions with the actual predictions, and we'll be able to separate training data from testing data. Thank you everyone so much for watching.